So the next presentation, we are going to cover WPA3 security enhancements, what are the beacon protections, and what are the new ciphers. Please join me to welcome Rasika to present the next session on exploring Wi-Fi 7 securities.
Good afternoon, everyone. Actually, I'm very pleased to be here. I came day before. I really experienced a vibrant kind of environment. So I think I know basically because of you have one inspiring leader. In that way, I really want every engineer here to try to become an inspiration to someone else. You all have the potential. In that way, I want to give that confidence first. So let's go through actually security point of view. Let's look at some WPA evolution and then basically Wi-Fi 7 perspective, what things basically required for the certification point of view. So we look at particularly the GCMP 256 introduction, and then some additional features came with Wi-Fi 7, particularly the hash 2 element and the beacon protection. So now to understand WPA, every generation Wi-Fi comes, Wi-Fi Alliance trying to uplift the security. In that way, you have to have some idea how this thing evolved over a period of time. So 11i 2004 ratified, which introduced AES, but we had TKIP as optional method. In that way, even Wi-Fi 4, we had this TKIP WPA implementation, and then you could go WPA 2, which introduced the AES. So when it comes to Wi-Fi 5, we keep the same kind of security, nothing majorly changed. You can deploy Wi-Fi WPA or WPA 2. In 2018, Wi-Fi Alliance introduced a newer security, WPA 3. So that way, when Wi-Fi 6 came in 2019, they basically deprecated WPA. In that way, in Wi-Fi 6, you can implement WPA 2. So now, in the WPA 2 world, always encryption being 128-bit, that was the sort of a de facto method. So when 11ax introduced towards 6 GHz band, they make a difference. Basically, we introduced WPA 3 in the 6 GHz band. You can only deploy WPA 3. So that's a sort of a major enhancement. So we can't bring legacy security to the 6 GHz band. That's the one thing to be aware of. In the 6 GHz deployment, you can't bring WPA 2, not even mixed mode, what we call transition mode. In that way, that's an important aspect to remember. So the encryption point of view, still 128-bit AES, and they gave a one option. You can go for higher security. That's only applicable for enterprise 190-bit mode. So that way, so now when it comes to Wi-Fi 7, they further tightening the security requirement. So now unicast traffic has to encrypt using 256-bit. So that way in the Wi-Fi 7, you cannot use AES 128 certification point of view. That's the one important thing. If you want to get your device to be certified Wi-Fi 7, it has to support 256-bit encryption. So now with the MLO feature, now it has to support across all the band. In that way, even 2.45 GHz and 6 GHz need to support this particular encryption, which is important requirement. So now Wi-Fi 8, we talked about, like I'm sure when Wi-Fi Alliance introducing Wi-Fi 8, they will uplift this further security. But we don't know which way. Most likely while WPA 4 will come, but we never know. But always anticipate some security uplift with the Wi-Fi 8. So now, in summarize, now if you want to deploy in that way, WPA 3 is the way to go. So now in the personal kind of scenario, you can deploy WPA 3 only. But this is the creating problem of what about existing client, whatever the legacy client we got. In that way, if you want to legacy client support, then you can deploy a mode called transition mode. But remember, transition mode only can implement 2.15 GHz band. 6 GHz, we cannot bring transition mode, okay? So that way, you can deploy that. But now, after a few years of deployment, even Wi-Fi Alliance realized most of the devices are not Wi-Fi Alliance certified. In that way, those devices not follow exactly guideline given by Wi-Fi Alliance. In that way, now a lot of devices struggle to connect this transition mode SSID. In that way, they came up recently another mode called compatibility mode. That means hiding the complexity of WPA3 information element from the legacy client perspective. Again, in the personal scenario, they came up with this deployment model. Okay? But in the enterprise, you can deploy WPA3 Enterprise, which is a 128-bit security for the encryption perspective. But if you really want sensitive environment, you can go with that 190-bit mode, which provide the GCMP 256. But 90% of the enterprises don't go that path. Why? Because they're not sensitive environment. Typically, we will go the 128-bit security. But again, this only supporting the WPA3 capable client. If you have a legacy client base, you have to go with the transition mode, which is again available only on the legacy band, 2.45 gigahertz. So now this is for the secure SSIDs, but if you want guest SSIDs on the newer kind of band, then Enhanced Open has to be used, which is again Wi-Fi Alliance certification program. But again, with that, if you have a legacy band, legacy client support, you can go with the transition mode. So now all of these provide PMF. That's the key feature. Why you want to go to WPA3 or Enhanced Open, which will provide the protected management frame that mitigate the denial of service attack. And then all of this method providing perfect forward secrecy, which is a good thing. And then WPA3 personal addresses something called offline dictionary attack. So that's the drawback of the WPA2 personal. Your home SSID password can be cracked. And then 192-bit mode, you can get some GCMP 256, a sensitive environment, you can go for that. So now some reference slide here, I don't want to spend too much of time, but this is where client devices identify what security being configured. So if you configure WPA2 enterprise, AKM value 1 and 3. If it's a WPA2 personal, AKM value either 2, 4, and 6. WPA3 enterprise, either AKM value 5 or 12. And then WPA3 personal, either AKM value 8, 9, or 24, 25. So this 24, 25 is a Wi-Fi 7 requirement. In that way, if you want to support Wi-Fi 7, AKM 24 is a mandatory requirement, okay, in the personal scenario. So now, Enhanced Open has a particular AKM value number 18. Now, encryption point of view as well, by looking at the Cyber Suite number, you can tell what is SSID configured for. So unicast traffic point of view, if it's a 128-bit encryption, AKM Cyber number 4. And if it is 256 bits encryption, Cyber Suite number 9. So that way 4 and 9 is the two unicast Cyber commonly being used. Broadcast traffic or management frame protection as well, you have particular Cyber numbers being used. So now all this information goes in one particular element. I think in the presentation we talk about some RSN element, troubleshooting, debug point of view. This is the element you need to look for. Security is sometimes easy to understand. If you look at this element, you can tell all about Wi-Fi security. So now if it's a broadcast encryption, unicast traffic encryption, and what AKM method being used, it will be listed here, and which method we use for the broadcast management frame protection will be listed there. So now, keeping all this particular in mind, what is the Wi-Fi Alliance required for your device to be Wi-Fi 7 certified in the security perspective? But in the Wi-Fi Alliance kind of feature list, security is not showing as a one feature, but underlying they have uplifted security. In that way, there's an advanced security requirement is there for your device to get Wi-Fi 7 certified. One is such, you have to support AKM 24. That's a one requirement which is important to get this certification. That means newer AKM value to be required. And the other thing, in the WPA3 personal scenario, there's a method called #2 element that is mandatory. So early stage of WPA3 personal, they had something called hunting and pecking. That is not recommended nowadays. In that way, #2 element has to be supported. So now other thing is actually Diffie element group number 19, which is providing a 256-bit elliptic curve. That is mandatory. You can go for group 20. It's optional. And then GCMP 256 support for your unicast traffic encryption is mandatory. In that way, unicast data has to be encrypted using GCMP 256. And beacon protection also mandatory in Wi-Fi 7. Okay, it is mandatory in Wi-Fi 6E as well. So they brought that same thing to the Wi-Fi 7. Now in that way, let's look at some of these three features, very high level. So now, if you implement in WPA3, we talked about, like the personal scenario, there will be two AKM. AKM number 8, standard SAE, AKM number 24, group dependent hash, or the AKM number 24 for Wi-Fi 7 support. In that way, when you configure SSID for Wi-Fi 7, at least these two AKM will be advertised. And then, if your device is Wi-Fi 7 capable, so then he's supposed to use AKM 24 and use GCMP 256 for unicast data encryption. But if it is not Wi-Fi 7 capable, they can use a lower AKM value. I think in the presentation, I think I saw basically there's a Wi-Fi 7 client compatibility issue. So sometime if your client is not supporting GCMP 256, even AP advertising the Wi-Fi 7, your client won't get Wi-Fi 7 capability. He will go back to the 11AX, which is the previous generation. Okay, that's keep in mind certification point of view. Now in the same configuration, if you go with the 11AX client, they will not support AKM 24. They will go back to the AKM 8, which is a previous generation kind of method security. So now, what is the importance of this? Why? Because sometimes most of your devices may not get Wi-Fi LAN certification, but still understand the requirement. If you are bringing that device to enterprise environment, enterprise vendors try to adhere to the Wi-Fi LAN's requirement. That means if your device is not supporting GCMP 256, even if it's a Wi-Fi 7 device, will not get Wi-Fi 7. In that way, at least even your device will not go through the program, try to adhere the guideline. That will minimize the compatibility issues. Otherwise, we will face this compatibility issue number of years forward, because it is having different kind of behaviors. So now, even you will see in the previous screen, sometimes it is not very clear. If you look at the Windows client, it will tell, if you issue the netsh command, whether we are using what AKM, what cipher suite, and which method we're using, hash to element or hunting and pecking, that detail showing in the Windows client in the newer operating system, Windows 11. Earlier generation, those details was not discovered, given directly. In that way, latest version of the operating system, Windows 11, they will provide that information in the client output. Look for those information there. So now the hash to element method, let me just go back. So now this one, as I discussed earlier, when the initial stage of the WPA3 personal, method we use called hunting and pecking, just to come up with that password element. So that has some kind of vulnerability. This was discovered and Wi-Fi Alliance addressed those through the uplifter certification program. In that way, nowadays, today, whenever you're using WPA3 personal, you have to use hash to element. So this was mandated in Wi-Fi 6E. Wi-Fi 6E. So now that's brought forward to Wi-Fi 7 as well. So sometimes you may not get a configuration option. As a vendor, if you enable for Wi-Fi 7 for the SSID, underline they have to do this. So which is advertising this in the RSN extension element, you can see whether it's supporting or not. So it's a requirement for Wi-Fi 6E and Wi-Fi 7 as well. So in the last, in the beacon protection, now beacon frame providing a lot of information. So if somebody can manipulate the beacon frame, you can creating some vulnerabilities. That means sometimes you can say transmit power control. You can say, hey, AP advertising you to go lowest transmitting power. That means basically you can force client to transmit the lowest power. So that creating a problem. And sometimes QoS element can be manipulated. That will creating a starvation kind of effect. In that way, by manipulating beacon frame, you can impact the client behavior. So the protection provided was called beacon protection. So now the way they're providing protection is we are adding an additional information element. So in that way, this will not affecting the legacy client. Why? Because if they don't understand the additional element, they ignore that. In that way, this will not provide the backward compatibility issue. So what they did was they used some information element using the protected management frame. In that way, this feature works as long as you implemented PMF. That means when you implement WPA3 or OWE, PMF is mandatory. In that way, you can get this protection in that kind of scenario. In that way, because they reuse the information element that did not add additional kind of complexity. Now, AP will generating some kind of integrity group temporal key, and they need to provide that key to the client. That means this only works if client associated. So if client is not associated, you can't provide this key. In that way, beacon protection works for the associated client. So idea is once you know the key, you can calculate the MIC value, and if beacon does not have a MIC value, you ignore those beacon. In that way, once you connect to the cell, you will have a way of authentication the beacon frame authenticity. So you can validate this is coming from the original AP or somebody in the middle playing a rogue role. So that's, again, this was there for the Wi-Fi 6E as well. They brought this to the Wi-Fi 7. Okay? In that way, those are the sort of underlying three things you need to be aware of, Wi-Fi 7 perspective. So keep an eye on, sometime if your client is Wi-Fi 7, not getting Wi-Fi 7, so sometimes the security uplift requirement may be the causing that problem. Okay? So with that, I will conclude the presentation. Thank you very much.
Thank you, Rasika. Okay, Shivam.
It was great. I have a question like, for example, in case of MLO, we have three different links, right? 2.4G, 5G, and 6G in a scenario. And the idea of enhancing the security is to make Wi-Fi more secure. But the problem is that IoT clients interoperability issues will still remain because we cannot be 100% WPA3 deployments. In case of the MLO, we can enable WPA3 for 6 gigahertz, but we need to keep option for 2.4G and 5G as a WPA or WPA2 to avoid the interoperability issues in that deployment. Do you see these securities getting better day by day, but we are also chasing the interoperability issues, causing us still the Wi-Fi being vulnerable no matter how better we make the security, because we cannot get rid of those WPA2 or WPA security in the real world.
Yeah, so in that way, now in the practical challenges will be now you cannot achieve with one single SSID. In that way, you have to create multiple SSID. One SSID with a transition mode, keeping happy for your legacy client, and then another SSID for WPA3 capable client that can get the enhanced security. In that way, this compatibility issue always will be there. That's why I think now the biggest problem is what percentage get the certification, what percentage does not get the certification. So if you bring devices to your environment, having Wi-Fi LAN certified devices versus Wi-Fi not certified devices, then you face this challenge. I don't think any easy way of, unless you control your end devices, in that way, unfortunate challenge will be there. In that way, Wi-Fi LANs trying to help uplift your security, but that does not really mean we can go there immediately. In that way, I think always we will face this challenge. I think practical point of view, I would keep 2 SSID. In that way, keep 1 SSID for keeping this legacy client mixed mode support, and over a period of time, see whether we can move those devices to the other SSID. That's the sort of practical approach I can tell. There are no other solution. You have to keep that.
So in addition to Shivam's question, so if we make AKM24 mandatory in Wi-Fi 7, how it will affect our mixed networks for the WPA2 coexistence? So is it okay the same? We will have to have the another SSID for the coexisting one?
Yeah, ideally now to better sort of thing, like a AKM 8 and 9, 2425, you can enable the one SSID. That means client is capable of WPA3. Right. But if you want to bring WPA2 client to the same SSID, you have to enable that legacy AKM value. But in 6 GHz band, you cannot do it. In that way, best solution is again, like mentioned, having a one SSID with mixed mode and give that to your legacy client and make other SSID WPA3 only. You can still have multiple AKM, Wi-Fi 7 or Wi-Fi 6 capability, but over a period of time, slowly see whether you can update those client base to the higher security. That's a sort of a security world point of view preference. But practical world, we all know it is not the how it works,
Yeah, Shrikant.
Hello. So there was an interesting question yesterday when I was at a college saying that free public networks like an airport or railway station, should I join or not? So I gave a qualified answer that maybe if you have a 4G connection, better to use that if you are paranoid about security, because even the OWE does not cover the authentication of the access point. We do have a program called SAE-PK, where basically there is a public key-based authentication mechanism. Do you see any progress in the implementation? Because today open Wi-Fi networks are real in the sense that many airports and other places, we don't have an easy mechanism unless something like open roaming becomes so prevalent, which it is not currently. So is there any pickup of that SAE-PK method?
Yeah, I haven't seen that, so now probably yes, we all understood basically in the public network, we have our own risk of, somebody can sniff that, but at least if somebody telling that at least your traffic is encrypted, I'm a bit more comfortable. Now in today's public venue, we all use open SSID, but we use on top of that some application level security HTTPS, so we make sure we use some secure website. We are not really sending our traffic clear text, in that way. I would say I haven't seen the SAPK deployment, but my advice is at least first make it OWE, which is much better than what we are today. Okay, and that way, even if you're not comfortable of having that authentication part, then we can look for some other solution, but at least to make OWE capable,
Actually, my worry is not so much about encryption. As you said, we do have tunnels for most useful applications. The worry is about the authentication.
Right.
So, which is where SAE-PK comes in and says that, any open access point, you can advertise the public key, which can then be used in the process to verify that it's a true airport Wi-Fi. Because anybody today has a mobile phone, they can radiate in free airport Wi-Fi SSID. So more than the encryption, I thought that the authentication was a much more crucial element. And your observation is that you haven't
haven't seen a practical deployment of PK.
Okay,
Thank you very much.
Yeah. Raju.
Yeah, in Wi-Fi 7, as you mentioned, right, it's probably for access points and routers, the security applies for the Wi-Fi 7 currently. But what is the future of for the IoT devices? Is this going to add this Wi-Fi 7 security for the IoT devices as well, or do you have any kind of comments on that?
Ideally, if you think about GCMP 256, those kind of requirement, I'm sure it's going to be IoT devices are going to be very hard, in that way. I don't see that GCMP 256, in that way, IoT kind of devices, that's where you keep that mixed mode kind of support, The SSID need to be there for your catch all kind of devices. I would say IoT will fall in that category rather than they will immediately going for GCMP 256,
Okay, thanks.
Okay, any other question? Yeah, Chetan.
In the security world, they are now talking about post-quantum cryptography, right, PQC.
Yeah.
Any talks about that getting looked at for Wi-Fi 8? Are they looking into any of the PQC methods?
I haven't seen many documents, but I yesterday saw one document from CWNP. They're talking about what is the solution for the post-quantum kind of, there's one document if you search CWNP document. But, again, gut feeling is some Wi-Fi 8, I would say some kind of method introduced just to addressing those as well. But we never know, in that way, not very publicly, not very clear, in that way there are certain talks about, elliptic curve, Diffie-Hellman is basically being now less secure, in that way, newer methods of A came, but I don't have a clear idea, but I saw one document yesterday, but I'll probably give that if I find it again,
Thank you.
Okay, yeah, Putrash.
Hello. Yeah. Right now we are saying that WPA3 is more security and it's too difficult to compute and all, right? But now we are having AI with us. So with that, I believe it will be possible somewhere other way. It's possible to crack it. So how we are going to handle that one in security side?
Yeah, can you, I didn't get your question clearly. So, just quickly, yeah.
Okay. So we are having AI, right? For WPA3 is more security due to computation and all.
Yeah.
But right now we are having AI with us, and everywhere we are using AI, to
okay.
break it, everything.
Right.
So maybe a hacker can use AI to compute that calculation, right?
Right.
So how we are going to handle it? Or
Yeah,
what you
that's what related to that question he asked, with the quantum computing, most of the security cryptography thing, we thought not unbreakable. Now it's going to be, we believing it's going to be breakable. That way, now post-quantum kind of resistance, what are the different methods we need to use? That's where world is heading. I think newer method need to be come, in that way, right at the method what I was talking about, more likely AI tools will quickly crack those things. That way, like the next 10 years, I'm sure newer method will be introduced to the Wi-Fi security.
Okay.
Okay.
Okay, email the question. Yeah, Hari.
Can you hear me? So coming to the desk networks, right? So in the open scenario, how are we applying the OW security in different bands? Like, is it
But
applicable?
now, I would say now the even Wi-Fi 7 point of view, they don't support this transition mode kind of concept. Okay, that way, in office environment, I would say enable OWE. Yes, some guests will complain, hey, they can't get into that because they bring all device. So you need to manage that client customer devices. Otherwise, don't go with this mixed mode support creating to SSID, enhanced open transition mode, which is not a big plus thing. In that way, even the guests give the highest security you can give, but some guest devices will be unhappy because if they bring all device, but you have to work around that, other than try to please every client device you bring. In that way, if it's a corporate environment, I would say I will enable OWE. Yes, understanding 5% of the client will be not connecting, but that 5%, you have to manage different way, rather than downgrading your guest security. In that way, go with OWE. That's the best,
Thank you.
Okay, rest of the questions we'll take during the lunch break. Give a round of applause for Rasika. Thank you so much, Rasika.